1 second. Where is the code? Oh.
Yeah.
So this was the code that checked in. It needs to. I need to add one thing and tweak something because kind of checked it in last night and I hurried it a bit. So let me give a 2 second example. Let's see. Then it's going to ask me. I need to put this on the command line, but for now. You can excuse me. So everything I don't have the actual node here, but that so what it does here, you see the SO. I'll explain everything and then I'll tell you what hasn't been done and which I will do and what's actually been done. So so what a quick primer on how Python works on your computer is if you are on Windows, somewhere it'll plant a bunch of DLLs and some .py files, and if you like you can go into the .py files and read in other imports because they will be importing other things. For if like I go, if I go to hashlib, if it's a .py file, somewhere in the file system, it itself will have import files. And if it's not, the other option is it can be on Linux it could be a URL, and on Linux it would be a shared object. So that would be compiled stuff that you get when you get the Python distribution. So if you've got a shared object or you've got a DLL, then that's where things kind of stop. This stuff here is stuff I read inside the DLLs or shared objects, but they're not really important, so I'll probably eliminate that. So basically, the way I see it is everything is a leaf except for the .pyc file, which is a node. The .pyc files are sort of ephemeral, and depending on the machine that the operating system you build it on, and the chips and everything like that, the hash will change. So it's an instance where I don't think that the actual node is important. There are no other real interim objects that are formed. So I guess the tricky thing is understanding that for the Python developers, for the sake of speed and distribution, have these shared objects and these DLLs. And so you will see a .pyd file, which is the Python version of a DLL on Windows, and you will see. Let's see, what was it? What's that? I think I've got an instance here. Yeah, you got the shared object here. That is brought in, and that's what'll happen on Linux-y type systems. So I the things that I didn't do, just because it took me a while to figure out how to do this. This is actually recursive, and I figure out what is what by using the the syntax tree. That's what this is over here. And so I tokenize things, and then I look for Where is it? Right here. Oh yeah, it's something that's an import or an import from, because there's more than one way you can specify an import into Python. And so the thing I forgot to do, the two things I forgot to do, one is the PyC file. That's trivial. All this was the meat of it. That'll be trivial. I will do it either today or tomorrow. And the other thing I forgot to do was the actual entry mode, which was the file I specified on the command line. And then I'll add a flag so you don't have to input things Yeah. So that's it. Quick. Any questions?
So just to make sure I'm wrapping my head around this, effectively what you're doing here is you've written this thing where you can give it a Python file that would be the Python file you would be choosing to run. It'll go ahead and parse that with the AST. You use the import modules, import lib, in order to go grab the particular module that is being imported that you're reading from the AST. And it's basically making the, I think, thoroughly reasonable assumption that the Python path is the same when you're going to be running the thing as what you have here. And you're going through and computing right now the SHA-1s, but you can come back and move to Gitoid hashes and do the mechanics of OmniBOR direct document construction and whatnot fairly easily. And so going through and doing that based upon the import stuff, which is a really sharp way of, as you said, figuring things out. Because if you look at the code you've written here, I can see probably 90% of your effort was figuring out the right hooks to grab. Because there's a lot in figuring out the hooks to grab. It's one of those amusing things. There's not a lot of code here. Once you figured out the problem, it doesn't look like you had much trouble with it. But the hooks can be very interesting. Have you given thoughts to next steps?
It needs to do a lot. I need to do a lot of testing and make sure I'm catching everything. But the primary next steps, the obvious ones are the actual entry isn't listed, and the PyC file isn't listed. And then I'll test, and I want to make sure all my assumptions are correct. And then hopefully I will take suggestions from other people who are looking at it and say, you can say, oh, you forgot. Have you, and of course I have to expand the README, make an actual proper README file so people can critique it, properly. And determine whether my assumptions are the same as everyone else's.
I have a couple of quick questions. So I skimmed this, and it looks like you can take any Python module sort of file name as input. Excuse me. You don't need to be in the executing program. You can point this at a Python package or module, and it'll scan it, ingest it, pull in dependencies that are present on disk, do the calculations. Because that's all because you're using ast.walk rather than looking at the current stack. Is that right?
Yes.
Okay. Could you describe again how you're caching this? So I see the outputs, that's great, but how is it getting saved? Yeah, you get the SHA-1.update. Yeah, you open for reading, but you're not writing it back into the file.
Oh, I don't think he's producing an OmniBOR file yet. He's just
okay. I wasn't sure if I missed that. You're just generating the tree. Got it.
I mean, because correct me if I'm wrong, Robert, but writing out the OmniBOR file is not the hard part of this problem.
Maybe I didn't understand. Maybe I didn't understand requirement. So I write out this file.
Mm-hmm.
Is
Okay.
there another file? Is there another file I should be writing?
And so you're writing out the
This one right here.
hi omnibor.sharone. Yeah, I think I'm missing. Okay, you're not embedding. You're writing out the
No.
tree. Got it. Okay. Yep.
Yeah, because I read the spec, and the spec said you could write a manifest file, and I felt that that was easier and better.
Absolutely can do. Yeah, some of the other tools, there's been debate about taking an option to embed the gitoid of the tree in the file, in each file, versus just outputting a tree. I just wasn't sure if you were doing one or the other. It's clear now.
Yeah.
And the other, I guess my question is, was there a reason for choosing to go down the path of ast.walk?
Oh, it's just an easy way. It was just an easy way to token it.
Okay.
Token it made sense to me.
Yeah, no, it is a canonical way to walk a module tree. It's great.
Otherwise, I would have been in regex city. I think because you really just have to, you really have to parse textual files is what you're doing. Or what I'm doing. I don't.
No, yeah, you shouldn't be trying to parse the files as text. AST.walk is the appropriate way to take a module as input and walk its dependency tree. But the other approach that I had been thinking of is to do this at runtime rather than sort of offline, right? This tool could take any Python module and walk its dependencies and output the hash tree. That is a fantastic tool. It's also a very different approach than at runtime. So I think we might want both, right? This might be a good audit tool, which is separate from at runtime checking what's actually in memory, what's actually in the stack. Does it match what I expected? And I hadn't really thought that we would want both until just now. I thought it'd be an either or, but seeing this, I don't know, I'm trying to put this idea out there for folks. Is there value in having both? Or
sorry, now that I unmute myself, let me throw out some. Oh, please go ahead, Dave.
I will. I'm nodding emphatically because what you're going to see from my demo is what you were just asking for. So what the JVM loads, but I think that there's a checksum between both. And it's not that you have to block things that you don't know the SHA of, but what you want to do is you want to start building indicators as to whether your environment has been compromised.
Yes, yes.
And I think that this is a phenomenal indicator. In other words, if you pre-generate stuff for a body of dynamic code thingies, and then at runtime, when they're loaded, you say, okay, here are the things that are loaded. Do we have a record of them? And my guess is that there will probably be a normal distribution or a common distribution of yays and nays. The interesting thing will be when the distribution starts skewing. The distribution starts skewing. In other words, you have a lot more things that are being loaded that you don't have a record of. That, in my mind, is an indication of a supply chain attack.
Well, what's funny is like I've had three different ideas since we started talking about this.
Yeah, and not necessarily true, David. Like it is a not uncommon thing in Python to modify the call stack at runtime.
I am not saying that it is definitive. I am saying that there are indicators. And I think that what we, at least the place more broadly that my mind has been going is we're managing systems by the metric ton. We're not managing systems by individual package, module, or running application. So for a security operations center, what they need to do is they need to look at statistical anomalies and see whether those statistical anomalies are leading to something. It helps them refine what they're investigating. And so I'm looking at the statistical anomalies as indicators, not definite stamps of a compromise. But it's like, this is more valuable for humans to go look at and analyze than this other thing.
Absolutely. High fidelity signal.
Yep.
Signal you don't drown in.
Yep.
Because the problem with statistical indicators is what you really want is what in physics we used to call a mesoscopic range of indicators, because in physics you're often dealing with sort of like a small number of macroscopic objects, or objects by the mole, 10 to the 23 multiple of them, and they behave differently. But then we have what we call mesoscopic physics, where you're dealing with a few hundred or a few thousand objects. And you can reason about a few hundred to a few thousand objects, but I don't think we can reason at the security level in moles, even though God knows we're trying.
We are trying. And
I have a mole of CVEs in my system.
I have a mole of open source packages, and there's a mole in my open source packages.
I'm going to start referring to the molarity. I feel the need to talk about the molarity of CVEs in the system now.
Yeah. So I did try to reserve some time. I want to switch to the Java work from David soon, but I dropped a link in chat. The corollary to your work, Robert, is the inspect package.
Yeah, thank you. I'm looking at that now.
And you can do things like look at this, inspect the stack and walk it in the same way that AST walks a module on disk. You can walk the module tree and call functions like inspect.getSource or inspect.getFile, which are going to be approximates, not necessarily always true. Read the documentation if you want to go down that path, and then also look up some of the discussions around this, because it's been a couple of years since I was in it, but I do remember some, shall we say, fun playing with these about 6 years ago in Python community in 2.7. So I don't know how much it's changed with Python 3.
I guess the question I have, and this is probably showing how little I understand what you actually want, is where would you launch? When would you run the generator?
Yeah, so for a runtime inspection, you can add a hook. You could define a module, and in the modules __, I forget the name of it, but there's an onload hook in a module, sort of a hidden property of them. When you import the module, it automatically does that. And at that moment, you could inspect the stack. There are going to be some learnings for all of us here, because some pros and cons of doing that is it's automatic. All a developer has to do, or a system operator, is say, load this module in every Python environment, and it's there. The downside, if you use an onload hook, is anything loaded after that in load order is invisible to it. So you might have to have both an onload and something else. That's where figuring out the whole solution gets a little bit tricky, but at least a proof of concept to be able to compare the static analysis you've just demonstrated and an onload hook for runtime analysis, and then see how they line up. We might learn that these two things have completely different checksums for the same file, and then have to figure out why. I don't know.
Well, this is where the whole thing gets extremely fun, at least to my taste, which is learning deep, dark secrets of languages is sort of a hobby, because it gives you a really deep understanding of how things work. And so I'm a little bit envious. This is going to be a fun adventure.
All right. Well, I've got some additional work to do then.
Cool. And thank you so much, Robert. This is a great direction in learning for all of us. With that, David, you've got probably the rest of the hour.
Okay, and can you all see my terminal window?
No,
Not currently.
it is black. Just it says you started screen sharing, but there's nothing there.
All right, let me try one more time. If that does not work, I'm going to drop out and, hey. Do you see anything now?
No, it says double click to enter full screen mode. But
Which also doesn't show anything.
yeah.
All right, so I am going to drop out, rejoin from my browser rather than the Zoom app. Give me 2 seconds, please talk among yourselves.
Cool.
Aren't David's cats the best cats?
Yeah.
Let's discuss.
No, it's fun, Robert, because you found an approach that I think has useful side effects with the Python stuff in the static analysis case that had never occurred to me, which is always, nothing delights me more than seeing people come up with ideas that haven't occurred to me. It's always fun, especially when I think I thought a problem through well. So.
Yeah, so simply because I misunderstood the problem.
I'm not sure that you did. I think the problem in my mind has always been that it's going to be complex. And I don't know the differences between representations on disk and the representations in memory for runtime compiled languages. It's not an area of Python that I really dug into before I could manipulate the stack, but I don't know how the stack is represented.
Well, to my mind, the only thing that would change would be the PyC file. It could change because the source files cannot change.
Always they can.
I don't know. How could they?
The source file on disk does not change, but it's
I see what you're saying. Okay.
it's quite possible for the representation in the stack to have been manipulated after the file is read in.
Yeah, okay, that makes sense.
And this is part of why the documentation for inspect even has little caveats like it tries to tell you the source code. Go ahead.
So speaking of cats, so I'm usually not on video because I haven't showered or done anything this morning, but here's the guy, and he's a big guy. We don't body shame around here, though.
No, what a sweet boy.
And he'll let me do this to him.
All right, so I can no longer, I joined from my browser. I can't share my screen from my browser. Let me try one more browser. Sorry for being a pain.
That's fine. So one other quick thing that I came across Googling a bit, Robert, that may be of interest to you, sys path hooks. Apparently, according to the PEP that they were defined in, this is a way that you can stick extra code hooks into the import mechanisms to instrument imports entirely as they happen. And I've not fully processed it all, but it does look like it really gets to the root of the thing.
Sys.path hooks. Oh, interesting.
Well, in particular, the PEP I think is even more to the point.
Yeah.
So we'll take a look at all.
Okay, I am failing miserably. I'm gonna try booting up a Mac. This is the downside of having a lot of security enabled in my machines. Should we talk more while I'm booting my Mac? Should we talk more about moles? No, I'm serious. You know, how do we start managing stuff by mole? How do we start building tools to allow mole-based handling of things.
Yeah. So the discussions I had with DFIR teams and CISOs last summer, data forensics and incident response, the challenge that DFIR teams have been facing and are increasingly concerned about is the flood of SBOMs and a very high noise to signal ratio. When I've described OmniBOR to those team leads, their ears perk up, like move up their head, like, whoa, because of the prospect of having a more dense information format for distilling signal from noise. If I ask them, or if the CISO asks the incident response lead, where is this package in our, this package, this version that we now know is vulnerable, it's an active exploit, we just got the alert. Where is this in our systems across the company? It's very difficult to answer that question. And this is in managing the moles of information, right? When the tools that people are using to generate that data might have periods, might have underscores, might have dashes, might have spaces, might have capitals in a file name, might have truncated a part of the version string. All of that makes the incident response detection very difficult. So they're excited by the prospect of just having a hash to look for and a hash tree across the whole corporate infrastructure. They are, however, not excited by the variance. The variance when you make any tiny change, and lots of places do in tiny injections as they're exploding packages, exploding open source. David, you have an echo.
That would be an understatement.
That is
You were saying?
So they were really excited by the prospect of higher signal to noise to manage the moles of information. I think it was a long-winded answer.
So I wonder if some of the work that Bharathi did on patch tooling handles some of the variation problem. Because one of the things that I've gotten some excitement from and the folks I've dealt with, because the not uncommon pattern when you have variations is to store the original and then as part of your build process to patch in your changes, is you can then actually get better fidelity because you can say things like, I'm going to associate a vex statement with this patch, which says any place I have this the hash for this patch, I know I fixed this problem. So now mechanistically, I can actually, in an automated way in real time, track the propagation of the fix through my systems, even if the reporting chain of that fix that is non-mechanical, the human reporting chain is messy, rather than having some program manager running a spreadsheet, which is intrinsically messy, you just keep rerunning the checks there and you can see it fade in.
David, we see you. Oh,
And now we don't.
Now we don't.
Peekaboo. This is a very serious community. Very
Yes.
serious.
Yes, I'm here for the seriousness. Yeah,
Really
if we're not able to get David's presentation today, so I'm not sure if David can hear me right now. I want to ask, is there value in just talking through it, even if we can't see the demo?
So David is technically not muted at the level of Zoom, but he does appear to be rejoining, from elsewhere.
All right, I will have to do a full run through. I will do the demo next week. I'll have to install Zoom on a Zoom machine and make sure I can share screens. I apologize for the noise.
It's okay. Do you want, Ava was just asking, go ahead, Ava, I'll let you speak for yourself.
Is there value in talking through some of your questions, David, even if we haven't seen the demo yet?
So hang on, let me kill myself from the other browser. So I don't really have questions. What the tool that I built does is it's a Java agent. So it's loaded very early in the JVM. And you're able to see the bytes of Java classes just before, after they've been processed by class loaders, but before the JVM actually takes possession and turns them into runnable code. And it emits both a SHA-256 of the bytes representing the class, as well as a Gitoid SHA-256 Gitoid URL. What I have discovered is deps.dev does not go down to a granularity for their SHA-1 or SHA-256 of files. They only go at the jar level. So
I'm actually actively talking to them, so I will add that to my talking to them. And because it actually does two dimensions of things. The first one is it's a useful thing to talk to them about. But the second thing is it demonstrates the degree to which we've got active stuff going on in the Java space.
Yeah. So the current agent simply emits this information. My next step is the step that Robert has taken. In my case, I'm going to build a Maven plugin that after classes have been compiled, but before they're put into a jar, the kind of zip file that contains a collection of classes along with metadata, that the source, a Gitoid and a SHA-256 for both the source that was used to compile a class and the class itself is put into a file that is then loaded into the jar. So in the case of signed jars, this will allow you to say, okay, here, it's not the full attestation that you would get from in toto, but it is a deposit in the jar file of what should be expected to be seen. Being able to say this jar file was made available, these are the classes and the SHAs for the classes and the Gitoids for the classes that we would expect, then allows you to do one level back. Once deps.dev will do a per class SHA, we can look up what jar files, therefore what packages a particular class may have come from. Now, the interesting thing here is there are things called Uber jars, and an Uber jar contains not just the code that was compiled, but all of the dependent classes. And those dependent classes are pulled from the other jar files that are loaded on the build system. Now, the advantage here is if we can do a backward lookup, even if you have an Uber jar, in other words, you don't know the provenance of all the class files in your jar, you still should be able to tie the provenance of what's loaded into the JVM to something that we see out in the wild. The other thing that's emitted as part of the each class that's loaded is the name of the class. And in JVM land, there's a one-to-one correspondence between the name of a class, the class file itself, and therefore you should be able to say SHA plus name should be resolvable once we get file level or class level granularity, should be resolvable to a known package. So if you see like, org.apache.log4j, blah, 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 and you see a SHA or a Gitoid that you've never seen before, that could indicate that the class file was messed with. And once again, I'm looking at these signals that this puts apart, this is separate from aggregating the signals into something that an incident response team would do. But if we have a series of these signals and they start becoming deviant, that's when I think analytics And whether that's machine learning based analytics, statistical analytics, or just like counting things up analytics starts coming into play.
Never underestimate counting things up. I came to realize at one point in my career as a physicist that both StatMech and quantum field theory primarily consist of counting, and that I was remarkably bad at it.
I think I would have more questions if I grokked more deeply everything you just said, David.
Okay. Is there a point in which your grokking pattern failed to grok what I was saying? If we could start at that point, I can clarify. Because if you're having problems grokking it, my guess is a lot of other people are, and
some of it is undoubtedly because I'm not deep in the Java ecosystem. I've never written Java in anger. So
there are other ways to read. There are non-angry ways to write Java.
I'm not sure. So that's part of it. The premise that having the SHA beyond just the jar level, but all the way down to the module level makes sense. Totally agree. I think I got lost at a tiny divergence in the SHA in one module, where you're talking about that, like, well, the log portrayed dot this dot that might have a different hash. If that hash is different, the hash of everything above it is different as well, for one. And I think the way this is true, I'm abstracting from Python and applying to Java here, so I could be wrong, but every minor version change, every micro version change of a Python module changes the SHA because it changes the content, changes the hash. Keeping a database quickly locally accessible of every hash of every leaf node and all permutations of resulting hashes at intermediate nodes up to the top jar. That's not, I think there was a leap in how you were looking at this that I hadn't made in describing that process.
So I think there are two separate dimensions to the hash tree problem. So one of the dimensions that we've been looking at the hash tree problem is the compiled code. So what source code resulted in a compiled artifact, and whether that's a class file or a .o file. What things resulted in that class artifact?
Yep.
There's a second thing, and this is, I think, more based around how Java works and probably how packages work, or packages, collections of intermediate compiled artifacts, which is, I have a SHA. One of the questions might be, what was the source code that led to this SHA, or the collection of source code? The other thing is, what package or collection of other things is the SHA part of? So that would be the jar file.
Okay.
And so,
well, I mean, there are a bunch of different ways actually you could split this in terms of thinking about the metadata, because I think part of what you're saying is, at the level at which I load classes into a JVM, the JVM has no concept of jar files. The JVM really only has a concept of classes, and to a lesser degree Java packages, where Java packages is a very precise term of art, not to be confused with the way everyone else talks about packages. But that when those things get loaded, you're essentially loading a bunch of these hashes in, and you could imagine this metadata saying, oh, if I know the hashes for a given version of a package, or I know the hashes that live in particular jars. And so if I see those hashes showing up in my running JVM, I can say things like, oh, you've loaded log4j version mumble mumble. How do I know? Well, I know what hashes I get for log4j version mumble mumble. And I may even know things depending on how things are put together, where it's like, okay, well, you've loaded log4j version mumble mumble, but you've not loaded JDNI realm.class. And JDNI realm.class is actually the one that contains the log4shell exploit. And so maybe it's the case that of the 1,500 things I need to remediate with log4shell, you fall low on that totem pole because you aren't really vulnerable to log4shell because the JDNI realm.class is not being loaded in you. I should still go clean you up as a matter of hygiene because God knows what the next guy is going to do. But for right now, you're not actively exploitable. You're just at risk. Did that make sense at all? I may have gotten carried away.
The principle does. The practice of doing that at mole scale is where I'm tripping.
I do feel like there needs to be something more written about the molarity of CVs.
So I also think that there's two separate modes that CISOs and security teams operate in. One of the modes is I'll call it incident response, but it's the oh shit mode, which is when something bad is happening. The other mode is we want to keep a pulse on the system to make sure that, or to have confidence that the stuff that's happening in the system is the normal course of stuff rather than some aberrant course of stuff. And I think that if we can bifurcate the discussions into those two modalities, the molarity, I think, is a lot more in the second, in the latter, which is the day-to-day operations. How secure is my cluster? Is adding this additional run module or update going to increase or decrease the security posture, the risk posture of my cluster? That's the day-to-day stuff. And if we can start building tools around both runtime and compile time analytics for OmniBOR to help inform the risk scoring of a cluster, that's the day-to-day work. Then there's the incident response work, which is there's a critical CVE, where is it in our system and how do we remediate it? And I think, Ed, that's what you were talking about. And having the hashes gives us an extra checksum and an extra prioritization. It reduces the uncertainty around where log4shell might be.
Yep. We do seem to be running up against the top of the hour now, though, and I apologize.
I got distracted as well. This was a good conversation. David, I look forward to that POC in hopefully 2 weeks. I'm going to say, I think we should cancel next week's because Ed and I will both be at RSA. Ed, how does that sound to you?
That sounds okay to me. I think there'll be several other folks also engaged in RSA who normally make it by this community. Yeah. I suspect Frederick will also be there. Frederick, as you might imagine, is slightly distracted by KubeCon this week. Just the tiniest bit.
Yeah.
Is there of the OmniBOR group outside the RSA? I mean, I'm in the Bay Area, San Francisco's closer, but I'm not registered for the RSA conference.
Yeah.
So I will not be there.
Let's do it. Robert is in town. Bharati, you're there. We might have a couple other folks. Let's do it. I know we're at the top of the hour, but I'm gonna.
So we can discuss this over the Slack channel, maybe.
Slack.
What time? Yeah.
Yep. All right. Cool. Talk to you later.
Bye, folks.
Here's all.